It's Ron Strahan with the LSU AgCenter. I'm going to discuss something that's pretty important, and that's calibrating our spray equipment. When it comes to spraying your pastures, it's highly important to have calibrated equipment. We end up using less chemical. We end up with a better kill on the weeds that we're trying to target as well. We're going to discuss a method known as the no-math calibration method, and it's in a handout that you'll be receiving as attendees to the Northeast Beef and Forage Field Day. So this handout is something that I want you to follow along with. Again, this is the no-math method of sprayer calibration. The very first thing that you do with this method is to measure your distance between your nozzles. And so we measure our distance between the nozzles, and this is about 20 inches. And so you look at your sprayer sheet, and there's a table, and it has inches between the nozzles on one side and the distance for a run that you'll make in feet on the opposing side. And so at 20 inches, you'd make a calibration run of 204 feet. Now you make this calibration run with no sprayer spraying at that point. You're going to just make that run, time yourself, see how long it takes to make that run. You'll come back then and collect out of the spray nozzles for a single spray nozzle. So the thing you're going to need here, you're going to need a tape measure that measures about 300 feet. You're going to need some flags to mark off your area that you're going to be making your run, the time run. And you'll need, of course, a stopwatch. And when you get back here, you'll need something to collect your spray solution in. So the very next step we're going to do is we're going to go and lay off this calibration run of 204 feet as the sprayer sheet tells us to do. So remember I told you this is the no-math calibration method. The math has actually been done for you. So we first measured the distance between our nozzles, and we determined that was 20 inches. And so we looked at this table here that's in our spray sheet, our calibration sheet, and 20 inches means we need to make a run of 204 feet and time ourselves. Well, what that number represents, that 20 inches, is actually the width of a rectangle. And that rectangle has a length of 204 feet. That area right there is 1/128th of an acre, or 340 square feet. And so we're interested in the amount of volume that's occurring in that area right there, that 1/128th of an acre. And because there's 128 ounces in a gallon, and this is 1/128th of an acre, then that is with that ratio there, whatever we end up collecting in ounces is equal to gallons per acre. So if we collected 15 ounces out of this nozzle right here, that means we're applying at 15 gallons per acre. And then of course, you would go back and check each nozzle to make sure it's putting out a similar amount. But that's really the math behind it. But you don't have to do that math because it's been done for you, because you have this handout. All you do is just look at the table. It's 20 inches wide on our spacing. We know we'll make a run of 204 feet. We'll time ourselves making that 204 foot run, and then we'll come back and collect for that amount of seconds here. So we determined that we have a 20-inch spacing. So according to the chart on our spray sheet, we need to go a distance of 204 feet, and we're going to measure that out right now, and then we're going to time ourselves going this distance. So that's what I'm going to do now is measure. "204 feet. So after about 3 times of making this run, Dave was pretty consistent, about 30 seconds for this 204 feet and for this four-wheeler. So he was trying to maintain a constant speed of about 5 miles per hour. If this were a tractor, you would note your RPMs on your tractor and what gear that you're in. You want to maintain a constant speed because speed is a very important component of calibration. So in calibrating our evenly spaced spray boom, We first determined that it was 20 inches between our spacing between our nozzles, and we determined that a run of 204 feet was necessary. We timed that run, it was 32 seconds. Now we're going to collect out of one nozzle for 32 seconds. Go ahead, Dave.
Ready, set, go.
So because our calibration course was exactly 1/128th of an acre, and there's 128 ounces in a gallon, Dave was able to collect 12 and a half ounces. So 12 and a half ounces, that means we're applying at 12.5 gallons per acre, because ounces equals gallons per acre in the 1/128th of an acre method with evenly spaced nozzles. Next, we're going to be calibrating a boomless sprayer. And a boomless sprayer will be calibrated in a similar method. It's based on the 1/128th of an acre method times a factor of 10. Now, there are a lot of advantages when it comes to a boomless sprayer. When you're spraying with it, you don't have that big boom sticking out that could get caught in a fence or in some trees. There are some negatives, though, involved with it, too. It's very much affected by the wind, and so you want to spray on a very calm day. You always want to spray on a good calm day if you can find one. But the boomless sprayer is very much affected by the wind. So the very first step in calibrating a boomless sprayer is to determine the effective swath width. And what you would do is you would allow the sprayer to spray at the RPMs that you're going to be spraying at, and you'll measure that distance. And then you'll take that distance in feet and multiply it times 80%. And that's how you determine your effective swath width. So when I'm calibrating a boomless sprayer, we have to determine our effective swath width. What I like to do is get in an area where it's very dry, like a gravel area or a dirt area, and allow the sprayer to spray at the pressure that we're going to be spraying at and at the RPMs for the tractor. And so we did that here, and now we're going to measure this distance right here in feet. So Dave? It's about 25 feet. So with a swath sprayer, you have to determine the effective swath width, because on the edges, the accuracy is just not there. So in order to determine the effective swath width, you take the coverage area, which we determined was 25 feet, and you multiply it times 80%. And so when we did that, we got 20 feet. That is the effective swath width. Then you look at your calibration sprayer sheet for a boomless sprayer, and you look, and at 20 feet, it tells you that you would need to make a run of 170 feet and time yourself. Again, at the RPMs that you were spraying at during this process right here. And that's what we're going to do next. We're going to make this run of 170 feet and time ourselves, and then we'll come back here and collect for that amount of time. So I mentioned when in calibrating a boomless sprayer that it's based on the 1/128th of an acre calibration method times a factor of 10. And the reason we go times a factor of 10 is because with the spray swath of 20 feet, your calibration run would only be 17 feet to give us the 340 square feet, or the 1/128th of an acre. So we multiplied actually by a factor of 10 to make that run 170 feet long. And then when we calibrate the sprayer, when we collect from the nozzle, we will divide those ounces by 10, and that will be actually our gallons per acre. So we determined for 170 feet that it took 25 seconds. And so now we're going to collect the volume for 25 seconds. So Dave is going to have to use this trash bag because this is a boomless nozzle and the droplets kind of scatter out. It's difficult to collect the droplets. So he cut the bottom out of this trash bag, this large trash bag. He's going to put this over the 5-gallon can, allow the spray volume to drip into the 5-gallon can and collect the sample. So we determined that we collected 100 ounces here. And remember, it's by a factor of 10. So you would divide that 100 ounces by 10. Our actual gallons per acre would be 10 gallons per acre, which for me is kind of low on the volume. I like to get a little bit more coverage, so we would go back, recalibrate, maybe slow down the sprayer, try to get up around 12 to 15 gallons per acre. But we ended up with about 10 gallons per acre because we have 100 ounces here that we collected in 25 seconds. We divide that 100 ounces by 10. That gives us our gallons per acre of 10 gallons per acre. So we determined that our spray volume is 10 gallons per acre. So what does that information mean? Well, with a sprayer that's 10 gallons, if the product rate was 1 quart per acre, you would just put a quart in those 10 gallons. If you had a 100-gallon sprayer, for every 10 gallons of water, you would put a quart of herbicide. So you could cover 10 acres actually with 100 gallons if you're spraying at 10 gallons per acre. But you would have to account for that and apply 10 quarts in that 100 gallons of water. When it comes to calibration, make sure you use your calibration sheet that will be provided to you as attendees of the Northeast Beef and Forage Field Day. Gather up a tape, measuring cup, and stopwatch. Remember, it's important to maintain your speed and always use clean water for calibration. And when it comes to calibrating and why it's so important, because it saves on chemicals. And you end up with an accurate application, which means you're going to have better weed control in the long run.